Hey guys, this question asks, what is the relationship between the compounds shown? Okay, so I have two Newman projections. I love Newman projections. To me, a Newman projection makes so much sense. I think it just is a wonderful way of looking at a compound. Basically, for those who have forgotten a little bit, maybe need some review, basically is if you have a compound like butane, see butane here, and a Newman projection, we basically pretend we're looking at the compound along an axis between two of the carbon bonds like that. So basically what you'll see is this carbon here, maybe this carbon there, and the circle in the back represents the carbon behind it. And then, all the other substituents will be kind of rotating around those two carbons. And so that's basically what a Newman projection is. So let's make sure we actually have the same compounds here. We have carbons 1, 2, 3, and then 4. Okay, let's draw actually some line structures here because this looks like it's kind of tricky. So those are the two middle carbons. Let's pretend this one here is the one in the front. Let's number this one 1, and then that one is also 1. And then the big one behind it is going to be number 2. So that's 1 and 2. Then this one will have 2 ethyl groups on it. Let's do that. 1, 2, and 1, 2, and a hydrogen. Okay, so there's a hydrogen there. This guy will have 1 ethyl group on it, 1, 2, and it'll have a chlorine and a hydrogen. So now if I pull my longest chain, it'll be 1, 2, 3, 4, 5, 6. So this will be a hexane molecule. Okay, let's do the same with this one. Let's call this one number 1 and this one behind number 2. So 1 and 2. The 1 has also the 2 ethyl groups, and the 2 has an ethyl group and a chlorine just like the other one. Okay, so they're definitely not constitutional isomers. They're not geometric isomers. Remember, geometric isomers are cis-trans isomers, so they're not going to be correct because there's nothing that's cis or trans here. You need to have, a compound that's like, you have to have a ring or an alkene. There need to be some sort of obstruction to the bond rotation in order to have geometric isomers. Okay, so now let's compare their stereochemistry to see kind of what we're talking about here. This compound is not, this carbon here is not chiral because you have 2 ethyl groups, so it's symmetric. I can pull a line through it here and get a symmetric, it'll divide it into 2 equal parts. So this is not a chiral carbon, but this one is. So we have 1 stereocenter. So we're only going to look at the back carbon and kind of determine what its stereochemistry is. Let's try to move everything so that it looks exactly the same. What if I move this chlorine so that it's in the same place as that one? So I'm going to move this chlorine here, and when I do that, this hydrogen will go there and this ethyl will go there. And as you can see, that's exactly the same as what I have here. So you have an ethyl in the bottom, I have a hydrogen in the top left, and a chlorine in the top right. So therefore, I know that these compounds will be identical. They are the exact same compound. They're actually what is known as conformers, which basically means it's 2 identical compounds, but they're just at different points in their single bond rotations. In other words, that's what happened here. This single bond between this carbon had just rotated a little differently. But the final answer is for sure going to be E, identical compounds. All right, guys, I hope that makes sense. Make sure you are an expert at Newman projections. Make sure that a Newman projection is like something that, just looks very everyday and average and just you've seen it a million times. If you are confused with Newman projections, build a model kit. Take those plastic models that you can get, build a couple of compounds, and then ask yourself, okay, can I draw it out? So build the compound and say, okay, what was it going to look like? And then you draw the Newman projection, and then you actually look at it and see if you drew it correctly. But being able to see in 3D is crucial to solving just about most organic chemistry questions. 3D viewing is very, very important. All right, guys, hope this was fun for you. If you have any questions, send us an email. We'd be happy to respond. Thanks for watching this video with Champion Tests. Have a nice day and enjoy your studies.